On 3.1, example 7, this one says find the limit as x approaches 1 for the square root of x minus 1 divided by x minus 1. So now we're into the examples where you pretty much are going to see a 0 in the denominator every time, and you have to think, what am I going to do? In this case, we again have the 0 over 0 problem. So what do we do? In this case, the trick is to, well, there's actually two ways to approach this, and I'll go through both of them. The first one is to multiply by what's called the conjugate of the numerator. And the conjugate is the same thing, except with the sign of the second term changed. So I'm going to multiply the top and the bottom by square root of x plus 1. So what effect does this have? Well, notice what happens when you do FOIL on this. The square root of x times the square root of x, that's x. Look what happens to the outer term, first, outer, inner, last, right? Root x times 1 is just root x. But then the inner term gives me minus root x. So those terms are just going to cancel each other out. So really, when I have this conjugate situation, what you're going to get is just simply the first term times the first term and the last term times the last term. So that's going to give us minus 1. And then in the denominator, see what we get. Nothing happens on the denominator. We just simply have to multiply those things together. But if you notice, now I've got the same factor here and here, so I can cancel these out. And that's just simply going to leave me with a 1 up here in the numerator. So what am I left with? I'll have the limit as x approaches 1 of 1 over the square root of x plus 1. At this point, I don't have a problem now. If I plug in the number 1, I'm not going to get 0 in the denominator anymore, so I can just do that direct substitution. So I'm going to get 1 over the square root of 1, which is 1, plus another 1, is 1/2. There is actually another way to approach this problem. Let me just show you how that is. In fact, we're going to kind of end up with what looks like exactly the same thing, but just in case you're interested in this method, alternate way to view this. We started out with this, the limit as x approaches 1 of the square root of x minus 1 over x minus 1. Now this denominator doesn't really look like the difference of two squares, but in fact it actually is. Let me show you what I mean by that. And just recall what the difference of squares is. Let me just write this in a different color. Difference of squares formula, if I've got a squared minus b squared, that factors in a special way. That factors to be a minus b times a plus b. So what I can think of this denominator is being the difference of squares. Well, what's the square root of x? Well, it's the square root of x. So it actually is the difference of squares. And I can factor it in that way. So this denominator factors to be the square root of x minus 1 times the square root of x plus 1. And if you want to verify that, just go ahead and do FOIL on this, and you'll see that you will in fact get the square root of x minus, or you'll just get x minus 1. So this is viewing this as the difference of squares. And then, of course, the same thing happens. This then cancels with this, and so we're just left with 1 over root x plus 1. And, of course, we just get the same answer. So it's another way to view it. If you prefer that method, feel free to do that. This conjugate thing, though, is really probably the more popular way to do this. In fact, we'll run into some other problems where we pretty much have to use the conjugate.